All right, so today we're going to be working on solving exponential equations. So we broke them up into a bunch of different types. So our first type right here is when you have a base with an exponent. And so 2 and 32 are multiples of each other. Like 32 can be written as 2 to a power, and like 81 can be written as 9 to a power. So when you can do that, we're going to rewrite it and just solve our exponents. So this side says 2 to the 4x, but 32 is 2 to the 5th. Now they're both the base of 2x, so they cancel, and we're just going to solve the exponent. So it'd be 4x equals, I'm going to distribute my 5 to both terms, so it'd be 5x minus 5. Subtract over my 5x, and we're going to get x equals 5. So this side, 81 would be rewritten as 9 squared. Bases are the same, so we're going to solve the exponents. So we have 2x equals, distribute your 2 to both terms, 6x minus 4. Divide your negative 4, and x equals 1. So what gets tricky with this is that 8 and 16 are not multiples of each other, but they're both factors of 2. So I'm going to rewrite them with both factors of 2. So 2 cubed would give me 8, and 2 to a power of 4 would give me 16. So bases can go away, and we have to multiply these exponents to each other. So I get 15x equals 12x plus 16. So we get 16 thirds is our answer. So this right here, 2 to the x, I'm going to rewrite 32 as 2 to the 5th. And now it's ready. The bases end, and we get x equals 5. Now they're not all where we can rewrite it. So you're going to have problems where you can't rewrite the bases. So we're going to end up with problems like the 4x minus 5. So what we do is you can natural log or log both sides. I have a preference to natural log just because that's what we use in AP Calculus. So I'm going to natural log both sides and use the fact that, remember, if I have natural log of 4 to the x, that x has to come out in front. Remember that? So that's really x natural log of 4 equals natural log of 15. To get by itself, you do natural log 15 divided by natural log of 4. And you can leave it like that. For me, if you're trying to match answers, you would have to make sure you close your parenthesis there and then do divide by natural log of 4. So this is x equals natural log of 15 over natural log of 4, which is approximately 1.95. So either of those answers is fine. So pause the video and try 2 on your own, and then when you're ready, unpause it and see if you're right. So when I natural log both sides, divide by 5. See, so I get natural log of 18 divided by, it's about 1.8. On this one, the first thing I have to do is subtract over my 3. Then natural log both sides, and this whole parenthesis goes out in front. Oopsie, I don't want an ln just yet. Oh yeah, I do want an ln. So when I do this, I'm going to have x plus 2, divide this over, would equal natural log 22 over natural log of 5, and then just subtract your 2 over. So that's your x, which is approximately negative 0.079. All right, what's nice on this one, when I natural log both sides, I get 3x times natural log of e equals natural log of 7. And when I type in natural log of e into my calculator, you get out 1. All right, you see that? Natural log of e, because they're inverses of each other, they will cancel out and give you 1. So really this becomes 3x equals ln of 7, and you can divide by the 3. If you forget, you can put divide by natural log of e. It just will never be written that way on a standardized test or something. If you wanted the decimal answer of that, it would be about 0.649. So down here, if the base is 10, The same reason the natural log of e is 1, log of 10 is 1 also. So 10 is the only time I ever use logarithms. So I would go ahead and solve it by like minusing my 4 over, and then log both sides. Log of 10 is 1, so it goes away. So then I'm going to add my 3, and then divide by 2. So this is your answer here, log 17 plus 3 divided by 2. So if I do log 17 and plus my 3 divided by 2, it's about 2.12. So try 2 on your own, pause the video, unpause it to see if you're right. So I'm going to subtract over my 5, log both sides. So I would leave it as log 8, which if you want a decimal, it's about that. All right, on to the back, type 4. So we're going to be rewriting these using the rewriting principle. Remember when we had like the b to the x equals y, and then we said log b y equaled x? We're using this property again. So for number 1, rewrite 4 to the second equals x plus 3. And then you're just going to solve. All right, this one, try on your own. Pause the video and then come back. So you should have written 25 equals x minus 4. So 29 is your x. So x equals 8/3. So this one, we write it, remember the ln has a base of e. So this becomes e to the second equals 3 to the x. I would leave it as e squared divided by 3. If you want the decimal, there it is. I love type 5 because type 5, you have the exact same logarithm on both sides, so they just cancel out and we get linear equations usually. Because what you're technically doing is raising both sides to a power of 4. So power 4 raised to that would cancel it on both sides. I guess technically you're raising these to the power of 2. So I should have told you to pause the video to make sure you can try the next 2 on your own. So pause the video, try the next 2 on your own, come back to see if you got it right. Subtract your x, add your 1, you get x plus 6. All right, so the last one we have to do is type 6, which is condensing. So first thing we're going to use the properties where addition means multiplication, and then we're going to rewrite it. All right, subtraction means division, and then we're going to rewrite it. So the first thing we need to do here is condense. And now we're going to rewrite 6 to the second equals this stuff. So this is multiplying, square that out. Anytime you have an x and an x squared, you always factor to solve it. So make it equal 0 in order to be able to factor. So what we're going to do on here is we're going to check for extraneous solutions. So remember that means to make sure that they actually work in our problems. So if I plug in 4, 4 plus 5 is 9, which is fine. If I plug in -9 though, like log base 6 of -9 right there, that's going to be not true. You can never log, no matter what the base is, a negative number. See what happens? Error. No, not a real answer. So you could never have inside right here a negative. So that was extraneous. So really 4 is the only possible answer. So try 2 on your own, unpause when you're ready to see if you're right. On this one, make sure you remember the base of log is 10. I'm going to factor out my 5 because I like to factor when it's smaller numbers. So I'm going to check 5 is fine. It makes both of those positive. When I plug in -4, 5 times -4 is a negative number. So only the 5 works. So condense first by division. Hopefully you already tried this. Rewriting e to the 0 equals that stuff. E to the 0 is 1. And remember, if they're fractions, you make them cross multiply, like make them both fractions and cross multiply them. So this is a 1. So 1 times that doesn't change it. And then solve. Bring your x over, divide by your 3. Plug in 1/3 into both of those, and it does not make 0. So we're good.